So hello everyone, welcome to my new video of C++ STL. This is lecture 2. So what is a vector? Vector is nothing but in short vectors are dynamic arrays only. Okay, so you have seen an array, right? You have seen an array. I will go in the same pace that what is a vector first, what is a vector we will see. So vector is nothing but a array is nothing but an array only, but it is a dynamic array. That is, it doesn't has any limited size. Got it? So and as you know that in a array you have contiguous memory locations. You don't need to, it's not like not like a linked list that you don't have a contiguous memory location. Vector also has a contiguous memory location. Please don't get confused, it has a contiguous memory location. This is very important point. Declaration, how to declare it? Very easy. Just write a keyword called vector, just write the data structure whatever you want to put inside it, and just write the vector name here. Okay, I will show you more declaration types. So yeah, and suppose with size you have to do, just mention the size inside the bracket. Just mention the size, whatever size you wanna have of your vector. Okay, so and yeah, one more thing, very important thing is that in an array, I will tell you just a small difference in an array and a vector. It's an important difference. When we declare an array, suppose a of 5, okay, and I this is an array declared, okay, I write a of 0 equal to 2, okay, and other values I haven't. So 2, here will be some garbage value, here will be some garbage value, here will be some garbage value, and here will be, all these will be nothing but garbage values, right? All will be garbage values, but this is not a case in vector. In a vector, when you declare, when a vector is declared, that is, I told you vector int, suppose you are declaring a vector of size 5, okay, and suppose I write v vect of 0 same as array. Yeah, you are right, it is same as array only. Vect of 0 is 2, so it will be like 2 0 0 0 0 0. Okay, all the uninitialized places are filled with 0. Okay, no, not to be confused with this, are filled with 0, with 0, not garbage value. Okay, this is a very important point. Okay, just note it down that whenever it is uninitialized, that doesn't means that there are some garbage value, but it has 0 in all the places. I will show you in a code also. I will show you in a code so that you will be clear with it. And okay, so this was vectors declaration. Then you have a, so yeah, input, how to take input for an array vector. So same as an array, you have to declare a for loop, just a small change, or even if you don't want to do, you can have it. So as we know that while declaring an array, or yeah, while declaring an array, we have to initialize a for loop. Unless you have the size n, you have to, yeah, int x, so x is an integer which will be getting inside the vector. Okay, c in sorry, I forgot to put this, c in x, right? So similarly, you can perform this in vector also. And one more thing, you have an option of doing this also, dot pushback function. I will be talking about pushback function a bit more. So what does this pushback function do is, it pushes the latest element. Like, see, actually it's like a stack only. I will be explaining a stack a bit after some time. It's like a, see, suppose you are declaring a vector and you are initializing. Now you are writing vect dot push back 3. Okay, suppose already you had in your vector 2, right? So if your vector see, this point is very important. Suppose your vector has no size initialized. Okay, these are two conditions. No size, suppose no size is there, then what will happen? It will be like 2. Okay, suppose already 2 was there inside it. Okay, okay, leave it, no 2 is there. So this 3 is coming here. Okay, the last position after 3, if I give something vector dot push back 5, it will be coming after 5 here, after 3. Got it? And there is no like like a size of this array for vector for now. unless you stop like pushing or you stop all the operations, and it yeah, it doesn't has any size for now. But suppose if you have declared the size with size, I will declare with size. What happens, suppose I have written vector int vect and 5, suppose 5 size is given now. Okay, in this case what will happen, suppose I give a vect dot pushback 3 here, pushback 3 at this point of time, what I will get is 5, sorry, 0 0 0 0 0. After 5 you will get 3. Got it? After 5 zeros you will get 3. So this is a very big major difference in a vector. I will show you this thing with code also. Okay. Okay. So yeah, this was one thing. Then we have something called dot size function. So yeah, this is a very basic thing that suppose you want to get the size of the current vector on what you are working. Okay, like here how here we didn't know the size, right? In this case we didn't know the size for now. We haven't declared any size for now. Okay, so in this case, suppose if you want to know the size, at what size is it right now, okay, you can just write vect dot size this function, and it will give you the current size, that is 2. Got it? So yeah, for getting the current size of the vector on which you are operating, you have a function called dot size. Then we have a note to keep on. Don't forget this thing. It is a very important note that the maximum size of any array or vector or any contiguous memory allocation, don't mark my words, you forget your array vector whatever, but mark these things. Maximum size of any contiguous memory location is 10 to the power 5 for online compilers, whatever you work on. And suppose you are declaring a vector or an array globally, you have the size like maximum size is 10 to the power 7. Okay. So the limitation is not on actually array or vector, but the limitation is on the contiguous memory. Limitation comes on this contiguous memory location allocation. Okay. Limitation here. Okay, so yeah, don't forget this point. This is very important point. These are like interview questions. Like these are theoretical questions. In code, you never need this, I guess. But if even if you need, yeah, okay. Then one more thing is that you have a popback function also. Popback function, what is that? Is a very small thing. I will tell you. Nothing. It has just like how pushback. What does pushback does? Just now I told you, right? That pushback pushes at the last point. We have a function called popback. Okay, so suppose you have this vector which we were working on currently. We have 3 and 5, right? Suppose I write vect dot pop back. You don't have to specify anything. Don't forget this. Don't confuse it with pushback. You don't have to specify here anything. Okay, it will push. It will pop this 5 out. So now you have your vector as 3. It will pop the last element. Got it? Clear? Pop back function also you are clear. Then you have one more important point you have is, suppose you wanna declare a vector with 3 3 3 3 3, like how with 0 it was initializing. Okay, what can you do? Simply you can just write vector int v 5 comma 3. So basically this is the size of what size you're declaring. 3 is the value which you want to enter in all your positions. Okay, so yeah, this is also one thing. So all these things are basically a code thing, basic thing. And then you have something called okay. Okay, yeah, we can push like this. As I told you, is done. Output is this. Output is okay. Suppose you wanna with all elements as 3, you can just write this vector int v 5 comma 3. Okay, then we have, as we saw, pushback and pushes an element to last of vector. Similarly, we have popback. As I told you just now about the popback thing also. Now, one important point is that you will be afraid to use, maybe sometimes some people get afraid that of using this pushback, popback, or dot size function. Okay, don't get afraid, because the time complexity, as I have written here, mentioned here, time complexity of both pushback and popback is only o of 1. Mark my words, Okay, so no need to worry about whenever you are using this size function, or whenever you are using pushback or popback. There is no time complexity, like it is O of one only. So yeah, so you can use it very easily. Then you have one more feature, as in vector you had, you can directly, copy existing vector into where v is a pre-existing v1 is the, yeah, v is a pre-existing actor and vector, and v1 is copying v. Okay, v1 is copying v. Understood? So time complexity of this is O of n. Okay, now in a array, listen carefully. In an array, suppose you want to copy one array to another. Okay, you need to write a whole for loop for it. There is no existing such function which you can use to directly do that, right? You have to use a whole for loop. In the case of array, use a for loop for copying. Okay, but in case of vector, no. This is the solution. You can directly write in this form, and yeah. But a problem is there, that, and yeah, this is not called by reference. This is called by value only. That suppose if you make any change in v1, it will not affect in v. So don't worry. Okay. Then the time complexity of this is O of n. That is, yeah, again a for loop only. It is taking the time complexity of a for loop only. Actually, initially it is performing a for loop only, but yeah, they have a feature like this. Okay, a vector has a feature like this. So don't worry. Sometimes it is like not suggested to use, copy a vector into another vector unless you need it very seriously. You can just, call by or pass by reference only, because that is a way where your time complexity can be saved. Because here the time complexity is a bit, more O of n. Here there is no like pass by reference. You are not copying anything, you are not performing any operation. You're just passing one you are just passing one array or a vector to another vector. You, like, suppose if you make change in v1, it will show change in v also. Yeah, and the change will be here, and you will put, that is the change what you have to do here. So this was, introductory lecture for pair and vector. I explained you in a way that I was in a six like pointers. So I explained you in this format that what is a pair or what is a vector, the declaration of pair and a vector, the initialization of a pair and a vector, then copying a pair or copying a vector also I showed you at last for a vector, then accessing the element of a pair. Yeah, this was important. A vector element is pair, accessed how you access your array element similarly. Okay, then you have why to use pair or why to use vector. For vector why to use, you have the clear answer that it is so like it is a dynamic array. So it's good to use. If you have limitations, then don't go for vector, go for an array. But if you don't have any limitation, where you don't know what can be your entries or what can be the size of those things, so use a vector. Now let's see the coding part, that how do we code a pair and a vector. Okay, come, let's see that. Okay, so here we have the code for a basic code for a vector, how you can use, like, make use of a vector. The vector, I forgot to tell you, for the pair, that it lies in the utility library header file, utility header file, your pair. Okay, for vector you have to write like this: include hashtag include vector. Okay, this will include all the things of a vector. And for a common, you can just write your bit slash std c++.h, that will be including all your algorithm, utility, vector, whatever else is there, math and everything. Okay, so yeah, now suppose to you wanna declare a vector. Simply you can ask the size. I'm asking the size here to the user. The user enters the size. That size I give here to like define the vector of that size and then I use that for taking the input. As I told you, it will be same as a array, and then I have written a print function for the this vector, which will be printing the values. You can see the use of the this vec dot size function also here, which I am using here, using dot size function to retrieve the current size of the vector. I am not passing n as an argument parameter here, because I know that I can use just this function to get the current size. So suppose if I run this out. Okay, so suppose if I run this out, it is asking me the size. I give it 5, and I give here one some values. I will give. Okay, and you can see it is printing a very cool. Okay, cool. So now let's go to some more functions that we were seeing. We saw a pushback function also. So suppose I am not giving any size. Okay, I am not giving any. Okay, so suppose I don't give any size. Okay, I will just write vect n. I will copy this vect dot size function. I will just use this. I will just write here this. Actually, we don't need this for loop. We don't need this for loop for now because you don't know. I'm going to use that pushback function to show you, to demonstrate you how that pushback function works. Okay, so I will just be writing that name of the vector dot pushback. Okay, and the value that you want to push back. Okay, so suppose I want to push back 5 into it. Okay, so yeah, this will be pushing 5 into it. Okay, and suppose here 8. Okay, yeah, wait, dot pushback, what is it showing some error? Okay, sorry, we don't need this. Okay, so now suppose if I run, you can see that we have pushed now I was showing you that pop back function, right? Pop back is a very cool function. You can just pop the latest element that you have entered. My latest element that I have entered is 8, right? So suppose if I use a pop back function, change it to pop back. So suppose I give it as pop back. This will be popping my 8 out. Pop back, sorry, no, nothing you want to give here. You just have to give this. Okay, so it will be popping the last element that you have entered, and 8 is now removed. You can see. So these are again some functions for vector that you can use. I told you one more thing that suppose you wanna copy. Oh, yeah, one more important thing was I wanted to show you that suppose if you declare a sized array, okay, a vector. Suppose you declare a vector of size already given. Suppose I give here 5. Okay, I will comment it out. This whole thing. Okay, this also will comment out. So suppose I am giving this 5. What will be the values that will be printed? Suppose I'm not entering any value into it. What will be the value that will be printed? In a case of an array, you get here garbage values. If you want to check it out, I will show you one example. Just a small example I will show you. Suppose I write here int vect, and this will be a array instead of this. Suppose this is 5 again, and I give here everything we need to change into vector. Uh, okay, and we need to give here the size also, and n here. So here I will be putting my n. Okay, so now we need to pass here our vect and comma 5. Okay, so now it's good to go. Suppose I run this out. See, you are getting some garbage values. 5 garbage value you will get. That will be contiguous. Okay, there is no doubt into it. Okay, you are getting 5 values. Actually, these are values, not address. So these are not. Don't get confused that it is not contiguous. It is a value, not address. Okay, address is contiguous. So yeah, you are getting here 5 garbage value. But this was not in the case in vector. In vector, all the elements are you are getting as 0. Okay, so this I wanted to show you. Okay, I will again put it back whatever it was. Okay, I wanted to show you one more thing, that suppose if I do here push back, okay, suppose I push back a value into it 5. Okay, so this doesn't mean that your all zeros will go, no, all zeros and after that your 1 5 comes. You can check this out for yourself. All zeros and a 5 entered, so the total size now is 6, not 5 now. Okay, okay, this was the thing. The copying thing I told you in pair, same thing works here. Okay, so this was all about vector, how, like, what all implementations are there of a vector and all. There are more many algorithms of a vector. There are more, keywords of a vector. I will be telling you that in some upcoming lectures, which will be like a more detailed video about a vector and a pair. So be stay tuned, and that lecture will also come into like some days. Okay, so keep coding till then. Jai Hind.